Question 13. What is the sum of the external angles of a nonagon? Now, if you have a quick look at the animation, you can see that the shapes drawn in orange are a triangle, a pentagon, and a hexagon. Inside the shape, you've got the interior angles, but on the outside of the shape, you've got the exterior angles, which are drawn in blue. Now, as the shapes shrink, I want you to imagine that the shapes are shrinking so small that the shapes almost disappear. They're just so tiny, but they're still there. But the angles themselves don't shrink. Okay, as you can see, the shape getting smaller, the interior and the exterior angles are still there. And then even when the shape disappears, the interior angles might have disappeared, but the exterior angles are still there. So the exterior angles, I'm going to pause it now. And you can see that this one was the triangle. And all three exterior angles now fit together to make a circle. So the sum of those exterior angles on the triangle is 360 degrees. This one was a pentagon. That had 5 angles, but the sum of those angles all fit together to make a circle, which is 360 degrees. This one was a hexagon that had 6 external angles, but the sum of them all fit together to make a circle, which is 360 degrees. So the moral of this story is that whatever the shape, if it's a regular shape, when you reduce the shape down, the external angles actually always sum or total to 360 degrees. So it doesn't matter whether it's a 3-sided, 5-sided, or 6-sided shape. A nonagon's got 9 sides. Just imagine there would be a circle with 9 angles. The 360 would be split into 9 angles, but the sum of them would be 360 degrees. What would have been a more interesting question and slightly more difficult if it said what was one external angle? So with a triangle, one external angle would be 360 divided by 3, which would have been 120 degrees. One external angle on the pentagon would have been 360 divided by 5, which would have been 72 degrees. And one external angle of the hexagon would have been 360 divided by 6, which would have been 60 degrees. And all that's saying is that each one of these would be 120 for the triangle. Each one of these would be 72 for the pentagon. And each one of these would be 60 for a hexagon. In a nonagon, we know that the sum is 360 degrees, but this would be 360 divided by 9, which would give you 40 degrees for each one of the external angles. It would basically look like this.